to Tucson or not, but maybe you've done some hiking before. Let's say you were hiking and you got to point A, you're sort of higher than everywhere else, right? Like imagine you're standing at A, you're really proud of what you've done.
Mm-hmm.
But you look and you're like, oh, I'm actually not at the top of the mountain, right?
Yeah.
You're just higher than your surroundings. And that's how I like to describe a relative max.
Okay.
What about B? What is B?
Relative min.
It's a relative min. Yeah. Okay. And so kind of the same idea is that it's the lowest point relative to its surroundings. It's like you walk down into a valley, but it's not the lowest. You were down here, at ground level at some point maybe before.
Mm-hmm.
Okay. Any questions on that so far?
No.
All right. Now the next big thing here is this idea of increasing and decreasing.
Mm-hmm.
So I'm going to draw some red dots here. Okay. And
Okay.
we only care about the X values. Actually, you got them there you only care about the X values here. So I'm going to draw a little number line. And the on the number line here, we're going to say whether the graph is increasing or decreasing. So maybe you heard this in class, but increasing is when it's going up and to the right,
Mm-hmm.
up and to the right. So like here, it's increasing. Here, it's increasing. Have you seen that
Yeah.
before?
Mm-hmm.
Okay, now you only care about the X values. You do not care about the Y values.
Okay.
All right, so it's increasing here and here.
Mm-hmm.
And it starts at minus infinity and goes to infinity. It has nothing to do with the fact that it's falling or rising. This just means to the left forever and to the right forever.
Okay.
Now you have to actually be able to give me those values, that interval basically. So how would you present your answer? Or do you know how to present your answer?
So for the decreasing
No,
interval,
just increasing, just increasing. We'll get to
oh,
decreasing.
so would it be negative infinity is, oh, okay, negative infinity and then
Well, how are you guys doing? Are you using interval notation or are you using something else?
I think interval notation.
Okay. It's a negative 1.9. So it's going, you go from left to right. That's the point.
Okay. And then it'd be 3.9 to infinity, comma
Good.
infinity.
Yes, good. Very good. Any questions on that?
No.
Okay. All right. So similarly, we can talk about where it's decreasing. So I'm going to do the same thing actually. I'm going to draw these red dots again. It's decreasing if it's going down to the right.
Mm-hmm.
So you have to sort of know the definition of both. Down and to the right.
Okay.
All right. So you could draw a number line. It's the same as the one we just did. An important thing here is to recognize again, it's only the X values. You do not care about the Y, just the X values. And for most of the graphs that we're going to look at, it's either increasing or decreasing. It's never going to be constant.
Okay.
So it's decreasing here.
Mm-hmm.
And it's always left to right. Like you read left to right, you do math left to right. I don't know. We do links left to right. So
Yeah.
all right. Any questions on that?
No.
All right. So next thing is domain and range. So think of domain as how far left question mark, how far right?
Okay.
So how
And
far
we
left does this graph go? Like I know it goes
um
down forever, but how far left does it go?
negative infinity.
It does, negative infinity. And how far right does it go?
Infinity.
Yeah, now for most of your problems, your domain is minus infinity to infinity.
Okay.
For most of your problems. All right, now the range, it's a similar set of questions. How far down? How far?
Negative infinity and infinity.
Yes. And that's because it's going, over here on the left. Okay, my cursor, where's my cursor? My cursor. Down forever and then up forever.
Mm-hmm.
But that is not always the case, right?
Yeah.
We'll see. We'll maybe see some things like that. Okay. Any questions on this before we look at another one?
I don't think so. And I think my dad sent you another problem
I
that I
did,
sent.
yeah, I did get that. It's being
Okay.
uploaded. It is ready to go. And you're welcome to send over as much as you want. That's a business phone. I don't look at it unless I'm working. So won't bother
Okay.
me. All right. This is weird. Your teacher's giving you weird problems. Okay. This one's
He's
different. So
really,
I'm actually gonna, sorry, go ahead.
he's really weird.
Okay. It is a good question. It's just not the right one for us to do next. So we're gonna look at something different.
Okay.
I'm gonna look at something more like this next. So that, you got minus x plus 1 plus 2. All right, something like this. Okay. All right, so here's a graph. It does go up forever. It does go down forever. We're going to focus on increasing and decreasing. So I'd like you to tell me where this graph is increasing and where it's decreasing.
It's increasing from negative 1.549 comma 0.215,
Okay, good.
and then it's decreasing from negative infinity to positive infinity.
No, no, it can't be decreasing everywhere, right?
Oh,
It's
yeah.
you want to identify these 2 points.
So then negative infinity to negative 1.549,
Yes. Anywhere else?
and then 0.215 to infinity.
Yes. Okay, good. So how would you describe A and B?
Um, uh, would I do negative 1.549 comma 0.215?
No, I'm looking for words like min or max. Sorry, just not, it should be more clear.
Oh, so A would be relative min and B would be relative max.
Yeah. Oh, I also saw that your teacher's using the word local. That's okay.
Mm-hmm.
Is that okay? Is that clear?
Yeah.
All right. So the next thing here is domain and range. Grab the graph again. Um, and it goes up forever. What do you
So
think
would
here?
the domain be negative infinity to positive infinity?
Okay. And the range?
Negative infinity to positive infinity.
You got it. You got it.
Okay.
Okay. All right. Now I am going to start. I'm going to start maybe munching on some food. So I do apologize.
It's okay.
But gotta eat at some point. So let me
Yeah.
give you another problem here. It'll be slightly different than what we've been doing. Might be easier, might be harder for you. I have no idea. Um, we're getting the graph so that we got something to look at here. All right, got the graph come in. Okay. All right, so here we go. New problem for you to look at. Can you tell me where this is increasing and decreasing, please?
It's increasing from negative infinity to negative 4.175, and then negative 1.397 to 2.572.
Right.
And it's decreasing from negative 4.175 to negative 1.397.
Okay.
And then 2.572 to negative infinity. Or, yeah.
Good. Now we haven't talked about this. We've got A, B, and C. Can you describe each of those?
C is the absolute maximum.
Okay.
A is relative max, and then B is relative min.
Very good. Now, I'm going to draw another graph here without giving a bunch of labels. What are A and B in the problem?
They're both relative maxes.
Yes.
Or,
And you can have more than one.
okay.
How about C and D?
Uh, Relative minimums.
And you can have more than one.
Okay.
All right, let's go back to this problem here. So because there's an absolute max or an absolute min, the range is modified, but the domain is minus infinity to infinity until otherwise. So, but the range is slightly different.
Okay.
You want to try give me the range on this?
Would it be
So think about how far down does the graph go?
a negative infinity comma negative infinity?
The range is just the y value. So just how far down does it go? What's the minimum? How far down does this arrow go?
Negative infinity.
Okay. What's the biggest y value?
154.96.
Okay. Now this is a little bit odd, but there's a bracket there. And the reason is it's included.
Oh, yeah.
Okay. Questions on this?
No.
Okay. Maybe a couple more here. So here's a new problem for you to look at. I want you to tell me where it's increasing where it's decreasing?
It's decreasing from negative infinity to negative 0.628. And would it be from 3 comma 0 to negative 7.533?
It's only the x values for increasing and decreasing, just the x
Oh, yeah.
values.
Yeah, 4.378.
Yeah, now in a multiple choice, they might have both been there. That's why I'm saying that. Yeah, I know you don't get that very often, but something to think about.
Mhm.
Okay, how about increasing? And that was good. I was deceptive. I didn't put that in, but yeah, that's something to consider.
Okay, and then increasing would be negative 0.628 to 3 comma 0,
Good. Anywhere else?
and then 4.387 to 5 comma 0.
What about all this other, what about all this others? Is it not still increasing there?
Would you add another one, or would it just be to positive infinity?
So again, up and to the right. You're trying to assign like, oh, it's got to be positive.
Okay.
Like, have you been up to Mount Lemon?
Not yet.
Okay. Let me quickly look like what the elevation of Mount Lemon is. It's very disappointing. Okay. So the elevation of Mount Lemon is 9,171 feet. Okay. You used to live in Colorado, I guess, is my
Yeah,
guess. Okay.
yeah,
There's this big, push to climb 14s or 12s. Is it 12 or 14s? I can't remember.
14s.
Right. So, I don't know. We're roughly whatever 3,000 feet. So we're going up to 91.7 feet. But in Colorado, what you're starting at maybe 5,000 feet,
Yeah.
or if you drive up the mountain a little bit, right? You're still going
Mhm.
up. Like even when you get past 91.71, you're still going up, right? That's the whole
Yeah,
point here. You're still going up.
okay,
Like imagine you're a hiker, you're still going up.
okay.
Now, have you climbed a 12 or 14?
Yeah, I have.
Wow, that's wild.
Yeah, I used to do a lot of backpacking over the summer.
Cool. My friend told me he got struck by lightning doing those hikes a long time ago.
Wow.
Yeah. Anyway, all right. So let's look at this one more time. Something else now. Tell me about domain and range.
Okay, the domain would be negative infinity to positive infinity. And then the range would be negative infinity, comma,
What is the smallest y value?
oh, negative 101.635.
All right. Now that one is actually included.
Okay, so the bracket.
Yeah. Okay. Now let's look at some of the other problems you had brought up. So I'm going to make a really simple one here. This is the point 2 comma 1, and this is the point 7 comma 8. Okay.
Mm-hmm.
What is the domain and range of this?
The domain would be
What is the leftmost x value?
1, and
Try again.
then 2, and then 7.
Okay. What is the smallest x value?
1, and then oh, yeah, 1 and then 8.
Very good. Okay. Now we can make this more complicated by graphing something that looks like this. So we'll go -3, 7, 2, -4, 5, comma 2. So domain, what is the leftmost x value?
-3.
Okay. What's the rightmost x value?
5.
Range.
7 and then 2.
So it's smallest to largest. It's the y values now. How to associate range with y
Oh,
values.
so it'd be -4 to 2.
But is that the largest y value?
Oh, 7.
Yes. Okay, so what are you going to do to remember this? Because it's a little bit of a confusing thing here.
I'll write it down.
Okay. Let me know when you're ready for another problem.
Okay. Okay, I got it.
All right. So the thing here again, the words are the more important thing, right? Domain is left to right. Range is, there's a couple of different words for range. You can use min to max, bottom to top, low
Mhm.
to high, whatever you like. Like you get the choice. But domain typically is left to right, typically.
Okay.
Go ahead and give this a try, please.
So domain would be -5, 4.
Okay, I agree. I'm gonna
And
write that down
then
in a moment. Is it bracket or parentheses?
um it would be brackets.
Because they're both included.
Mhm.
All right, range.
And then the range would be 1,
So you're saying the
comma
smallest y value is 1. There's no y value smaller than 1.
oh, it would be 3, -3.
Okay, and then what's the biggest y value?
0.
So you're saying there's no y values bigger than 0.
Oh, 3. Sorry, I'm thinking the
Okay, so like most students, you're struggling most with range. So for the next problems, I just want you to focus on the range. Just tell
okay.
me the min to the max, the smallest to the top. So just the range.
3,
This is 3.
-3, and
Okay,
then negative infinity
so you're saying it goes down like that?
or positive infinity.
Okay, we're gonna get it. Don't worry. It helps if it's explained correctly the first time in the classroom, or first by me, which we didn't get. So, all right. Imagine that's filled in. Just the range, please.
So it'd be 1, comma, infinity, -1, comma, infinity.
Okay, we'll pick that. Now, infinities always get parentheses. Always get parentheses. Always. Always.
Okay.
Always. Always. All right. Here's another one for you to try. Just give me the range of this one, please.
Parentheses, negative infinity, comma, 2 brackets.
You got it. And it's easy. Don't let that be the big thing. I mean, it's the numbers that are more important to start.
Mhm.
Okay. Let me do one more, and then we'll go back and look at your problem. All right. So give me the range on this, please.
It'd be -4
All right.
or,
Good.
oh my -5,
Good.
comma, positive infinity.
Okay, looks like it goes up forever.
Yeah.
All right, very good. So now let's go look at your problem, and we're going to answer a bunch of things. This looks like it was taken in class. Is this a projector or something?
Oh, I just took that on my phone just now.
Okay, okay. Just print it out.
Yeah.
Okay. All right, let's start with the x-intercepts. There could be more than one, there could be none.
Negative 11.828 comma 0 and negative 6.172 comma 0.
Okay. Can you estimate the y-intercepts?
The y-intercept may be about 70.
Can you give it to me as an ordered pair, please?
Yeah, 0 comma 70.
Okay, and tell me about point A. What's a name you could give to A?
Absolute max. Min.
That's the okay, it is the absolute min. Very good. Okay, that was kind of a diversion. Let's see if you're still remembering things. So now tell me about where it's increasing and where it's decreasing.
It's increasing from -9 to positive 7.248,
Okay,
and it's decreasing from negative 20.113 to
that's
negative
that
8.
that's the y value.
Oh, negative 20 then.
I let you talk me into that too. Yeah, it's -7 there. Or positive.
Okay.
Okay. So what about the -9? Okay, good. What is the domain and range?
The domain would be negative 20 to positive 7,
Okay, that's domain. Got the wrong spot. All right.
and then range would be negative 8 to what number is that? 248.
Okay. All right. So I mean, I feel like you understand this. So I don't know that we need to do any more problems on this. Um,
Okay.
is there something else that you would like us to cover, or do you want me to pick stuff? What would be best to help you?
Um, I mean, you can pick stuff because it's mostly just review on a lot of things.
Okay. We'll go back over some of the stuff we were doing the other night. All right. I'm just pulling up some problems here. All right. So I want you to use synthetic division, and I want to know the remainder of this. I'm just going to step away for 30 seconds, but I'll be right back.
Okay.
All right. Any questions for me?
I'm not really sure what to do with the x plus 4.
So you got to figure out what number goes in the box.
Would it be a negative 4?
Yes. It's setting it equal to 0.
Okay. I got a remainder of -9.
Okay, let's take a look here. So this is -28, -9. Good. All right. So have you try a couple more? All right, here's one for you to try.
I got +9 is the remainder.
Okay, any questions on that or anything you're unsure about as far as how to do this?
I don't think so.
What does it mean if the remainder is 0?
Um,
Okay, if you don't remember, that's why I'm throwing that out there.
yeah, I'm not really sure.
The remainder of 0 means that the factor at work, it's a solution, a root.
Okay. Yeah.
Okay. We were using that like it would tell you in some of your problems, it would say like this is one of the factors, and then you would reduce the degree of the polynomial and then factor to solve.
Yeah.
Okay. Any questions on that?
No.
Okay. All right. Want to solve some equations? Have you solved some equations? Start with this one here. I'm happy to give a hint if you're not sure how to start.
Yeah, I don't.
You can always factor out a DCF.
Okay.
So is there something that goes into all three? Maybe you have no idea what I'm talking about. That's okay too.
Um, would it be a 1?
One goes in everything, so that's you don't talk about that. There's an A that goes into everything.
Oh, okay.
So tell me what goes in parentheses when you divide an A from everything.
So it'd be a squared minus 9a plus 14.
Now, can you factor what's inside parentheses there? Two numbers that multiply to 14, but add to -9.
Negative a minus a minus 7 and a minus 2.
Okay. Now you set all the A terms, and there's three of them. You set all the A terms or X terms, or whatever your variable is, equal to 0. So A equals 0, A minus 7 equals to 0, and A minus 2 equal to 0. Could you solve those
Okay.
three equations for us, please?
Yeah, so the first one would be a equals 0.
Good.
The second one would be a equals +7 and a equals +2.
Good. All right. So you ready to try one like that?
Yeah.
Um, Here we go. So This one is just like the one we did, kind of. I mean, it's different numbers, but give this one a try. I'm just looking for the final answers. And you can, of course, ask me some questions if you have any.
Okay. So would it be x equals positive 8 and x equals negative 5?
You're missing one of the solutions. What did you do first? What did you factor out?
Oh, and x equals t.
So in this case, the variable is t. So you would factor out a t squared from everything.
Oh, so it'd be t squared.
So what did you put in parentheses here?
X minus or t minus negative 8 and t minus positive 5.
Because you gotta be
T
careful.
plus.
Here's what you said. I don't think you meant that though. You meant t minus 8 and then t plus 5. You have to
Yeah.
just be careful how you say it, especially when you're communicating. All right, so you have to set all of these equal to 0. All right. So there's 3 solutions. Well, t is 0 and the other 2. Don't forget that first one. That's the one most students forget. That's why I tried to emphasize that in the previous problem.
Okay.
All right. We're gonna do kind of one more together here. I've kind of been shortening lessons lately just because of fatigue and things like that, but we'll
Yeah.
do one more together here. We've got more time, a few days. So one of the things you should notice by now, it maybe hasn't been said, is there's actually 3 solutions to this. It's whatever the exponent is. Okay. Now you want to get everything on one side.
Okay.
Okay. So now this looks more standard. You typically want it always equal to 0.
Mm-hmm.
Okay. Now in the previous problems, we've been factoring out. It's the same here. What are you going to factor out from both?
An x squared, yeah. So
So
then
what goes,
it'd be x squared minus
try again?
x minus um a 3 and yeah, just a 3.
Now you set both of these equal to 0. X squared equals to 0. X minus 3 equal to 0.
So it would be x equals 0 and x equals positive 3.
Very good. Okay. Yeah, we're going to stop here for today. Good job.